start at, and come to 0, bounce at 0, and go to 2/3. I'm going to bounce. Hold on. Something went horribly wrong here. This is a 3. Hi. See, this is why you do this to check. This is legitimately why you do this to check. Get out of here. If this is a 3 as it should be, this is 9 as it should be, and then my end behavior looks like, so this is my behavior of the graph. And so here I'm going to come in at 0, bounce, go into 2/3 and bounce, and hit 1 and go through. Okay. So this is at 0, this is at 2/3, and then at 1 will go through. So that's just another example just to kind of crunch on. You won't have anything this awful by any stretch of the imagination, as you've seen from the homework. Okay. Any dire questions on any of this before we go on? I'm not seeing any. All right. Give it a try. It's really not as difficult as it might seem once you start crunching through it. Clicks real fast. This is one of those sections, once you do it, it's like, oh, okay. All right. Well, if we're done on this, let's go ahead and do, can I go back? I want to go way back. All right, so we're going to do dividing polynomials. So this is the second thing we're going to be doing today. So if you've done polynomial, oops, there we go. So we're going to be dividing polynomials. And so we're going to divide it longhand twice, and then I'm going to show you how to do it quickly. You have, for something like this, you have to do longhand. For something like this, you can do quickly using synthetic division. I'll show you how to do that. So let's just get some names out of the way. So P, so all of these, so this means this is polynomial, this polynomial, this polynomial, this polynomial. What we call this is what we're dividing, so let me kind of go through the parts real quick. What is getting divided is called the dividend. What you're dividing by is called the divisor. So this is the dividend, this is the divisor. What you get out of it is called the quotient. So that'll be the quotient, and then what's left over is the remainder. All right, so let's explain how to do this shortly. Have you guys done long division at all? Yes, no? Polynomial division? Yeah. All yeses? Okay. I mean, if someone says no, I'll go a little bit slower, but you've seen it all before. I'll still go slow just in case. If there's like 5 yeses, you don't want to be like, hi, I'm the no. All right. So what we try to do here is, so when we come to polynomial division, what we want to do is we want to figure out what do we multiply. Let me just write, hold on, make sure I'm on the right layer first. So here if we have 4 divided by 480 to 0. So when we do this division, we're going to say, we just kind of look at it in chunks, right? So what times 4 gives me 4? Well, that's 1, right? And I put 4, copy it down, get 0, pull down the 8. What times 4 gets rid of 8 would be 2. So minus 0 minus 8 gives us 0. Pull down the 2. What times 4 gives me that is 0. So minus 0, 0 gives me 0. Pull down, or gives me 2. Pull down the 0 is 20, and then I get a 5, right? So that's how you do normal division. As you just kind of chunk it out, right? That's the same thing we're going to be doing here for our polynomial division. And so here we're just going to chunk it by term, right? I want to get rid of this term. So I'm going to multiply, what do I multiply by x to get rid of this term? Well, that is 6x, because 6x times this will give me 6x squared. Then I also have to multiply 6x by this, it'll be minus 24x. And then I take this whole quantity and I minus it out from what's above. And so here, this gives me 0. And if it doesn't give you 0, you've done something wrong for at least polynomial division. Here, I'll have minus minus, so that's a plus. So plus 24 x minus 26x will give us minus 2x. I pull down the 12. So here, well, what do I multiply? Now I want to get rid of the 2x. Well, what do I multiply by 2x, or x, to get negative 2x? Well, that would be just minus 2. So this minus 2 will give me minus 2x. So minus minus will give me plus 8. And then I'm going to negate the whole thing across. This gives me 0 by definition. And then 12 minus 8 gives me 4. So I have a remainder of 4. Okay. So here, the divisor, so this, now that we have everything, so here the dividend is the 6x squared minus 26x plus 12. The divisor here is the negative x minus 4. The quotient is 6x minus 2, and my remainder is 4. When I have you guys do this, I probably will I'll say what's dx, what's qx, what's rx when you crunch through it, right? And so let me just label all that for you. So here we'll have px. Actually, let me just write it in this form. That way I can have all of it at once and not have to write so much. And you don't have to write so much. So here, I'll have 6x squared minus 2 plus 12. So that's my px equals my divisor, which is in this case x minus 4, times my quotient. My quotient is up here, so it'll be 6x minus 2. And then plus my remainder, which is 4. And so actually, if I crunch this out, I'd get back this number. Okay. This is how most of you have seen to write it. Some of you have written it this way. It's kind of 26x plus 12 divided by x minus 4 equals 6x minus 2 plus 4 over x minus 4. Some of you have seen it this way. You give it, I've seen them both ways. Either way you do it on the homework's fine. When you actually do the exam, they'll probably say dx and then you'll have a box. qx and then it'll have a box. So you're just going to put in things into the boxes. Okay. All right, so let's do the more complicated one. So let's crunch through this. And so here, I'm going to rewrite this in long division form. So I'll have 2x minus x plus 2 divided by the quantity of 8x to the 4th. I'm going to plug in a 0x cubed. Technically, this is 0x cubed. This is important to do, especially when you do in synthetic division. Plug in your non-existent terms so you don't goof something up. Because if I didn't plug that in, I might accidentally divide my cube term by my square term. It's easy to do. So always put in your empty sets. So here, if I was looking at this, if I have 8x to the 4th and I want to get rid of 2x, and what do I multiply by 2x squared to get rid of 8x to the 4th? Well, that'd be 4x squared, right? So I'm going to multiply all this by 4x squared. So we minus the quantity. Let's go ahead and leave that. So 4x squared times this will give me 8x to the 4th, which is what I desired. 4x squared minus this will give me negative 4. So minus this will give me negative 4x cubed. And then 4x squared times 2 will give me plus 8x squared. Crunch all this down. This is 0 by definition. So I get minus minus would be a plus 8x cubed. 6x squared minus 8x squared would give us minus 2x squared. And then I just pull down the 3x. What do I want to add here? Well, in this case, I just want to get rid of, I'll just add 2x. So 2x will be the next thing here. So this will be minus 2x times this would be 4x cubed, which is what we desire. This will become minus 2x squared. And then this here will become plus 4x. Yep. All right, so here we go through this, and so, oh, no, this would be plus 4x, sorry, plus 4x. So when I crunch this down, I get 0. When I crunch this down, I get 0. When I crunch this, so negative third minus 4x will give me minus 7x plus 1. And since this right here is of a lower degree than this, we're done. We just write that as a remainder, so minus 7x plus 1. Okay. And so, so once the remainder is smaller than your divisor, so once what you have, you're done. Okay, so this is how you do long division for larger things. So technically, any two polynomials I give you, you can divide them and tell me what the divisor, the quotient, and the remainder is. These two are already given. I might ask them for freebie points, right? So that's how you're supposed to do long division the long way. What I'm going to teach you how to do is what we call synthetic division. Okay. And I'm going to be very careful when I do this because I almost always do it the other way. And so here, so we're going to divide this using long division. So x minus 3 of 2x squared minus x minus 3. So when I do this, I'm going to get 2x here. That's the first thing. So I'll get minus the quantity of 2x squared minus 6x, minus that out. Minus minus gives me 5x minus 3. Circle down the 3. And then I'm going to plug in 5. So it'll be minus the quantity 5x plus, nope, minus 5x minus 15. That makes that a plus, comes down, and I get 12. Okay, so that's how you would do it if you use long division. Now we're going to teach you what is called synthetic division. So you're going to have x minus c. What you're going to do is you're going to put c here in a cute little box, and then you're going to have a2, a1, a0. So your coefficients going down. You're going to pull this down. So a2 is just going to come here. You're going to multiply this by your c. You're going to get some value, you're going to bring it down. You're going to multiply this by your c. You're going to get some value, bring it down. And so this will be your remainder. This is your remainder for this. This will be let me write b0, and this will be b1. So whatever values you get here, you can just read backwards. This is actually easier shown than explained. So let's actually do this. So x minus c, so c in this case is 3, right? So x minus c. The way I was taught it, we won't get into it. Mine looks exactly the same as this. This is a better way, so let's just teach it this way. What are my coefficients here? My coefficient for x squared is 2. My coefficient for x is -1. My coefficient for x to the 0 is -3. So I just write those down. The 2 comes straight down, so this is still a 2. I multiply that by 3. So I multiply by 3, I get a 6 here. I add, so here we're doing addition here. When I did it, you actually did subtraction, and it mimicked this perfectly, but we'll do it this way. So it's addition. So we add these two numbers, and I get 5. So here, 5, we multiply that by 3. We get 15 here, add that up, and we get 12. And so here, and I read this backwards, so I'll have, this will be my b naught, this will be my b1. So I'll have 2x plus 5, remainder 12. Okay, and so this is probably the way you've seen to do it and the way you were taught to do this. So let me do it with these ones. So here, if I have x minus 3, if I want to do synthetic division, 3 is what goes in the box. So it's whatever's minus this, right? Here, my x cubed is 2. My x squared is -7. My x term is a 0, right? There's technically a plus a 0x right here, right? So I put in the 0. If you do not put this in, your answer will be wrong, right? So the x term is 0, and then you have a 5, and then we'll just crunch through it. So the 2 comes straight down, just drop down the 2, multiply by 3, we get a 6 here. Add those up, I get -1, -1 times 3 gives me -3, add that up, I get -3, -3 times 3 gives me Negative 3 times a positive 3 gives me negative 9. I almost left the negative off. And then when I add this up, I get 4. And then you just read this backwards. So I'll have 2, so this will be minus 3 minus x, 2x squared, with a remainder of 4. Okay. Let's do another one. So this will be a 2. So it'll be x minus a minus 2 is the way you read that. So you put in negative 2 here. Here, my cubic term is 4. My square term in this case is 0. So please put in the 0. If you don't, you're doing it wrong. So notice here there's no x squared, so there'll be 0, minus 3, and then a positive 2. And then you just crunch it down. So negative 2, so this becomes, so the 4 comes straight down. So this is 4 times negative 2 becomes minus 8. Minus 8 times 2 gives you 16 times plus the negative 3 gives me minus 13 times the negative 2 gives me minus 26 plus the 2 gives me negative 24. So here I have a remainder of negative 24. And then this is my 0 term, so 13, oops, 13 minus an 8x plus 4x squared. I kind of write it backwards because then I don't have to pay attention too much. And so here's your solution to that. If we're going to write, and just for kicks, let's write one of them in. So let me write this one in the term. So here times my divisor, so my dividend equals my divisor times my quotient, which would be this. Plus my remainder, which would be plus a negative 24. Just that makes it clear. Myself a little bit. And so that's how you write it out long. Have you guys done this before? Does this all seem pretty familiar and pretty straightforward? Yes, I have. Yep. Okay. So there shouldn't be any huge surprises for this one. Let me just crunch through the last little bit and then we'll answer some questions and we'll go from there. All right, so the remainder theorem. Basically, when I divide, if I divide by c, the remainder is the same value if I plug in c. So, so I want to find p minus 2. So if I wanted to figure out, if I plug in negative 2, what do I get out of this? I could actually crunch through all the numbers, which in this case isn't horribly terrible, right? Or I can just divide by x plus 2 and figure out what the remainder is. It actually ends up being the same thing, right? It actually ends up being the same thing. So here, if I was going to plug in, so here'd be x minus 2, which gives you x plus 2. So if I was dividing by that, I get negative 2. And I want to figure out what this is. And so here, I'm just plug it in. It's 3, 5, minus 4. There's no x squared term, so 0. 7 and 3. Crunch through this real quick. 3 comes down, I get 3. Up gives me minus 6. Crunch down, I get negative 1. Gives me positive 2. Gives me negative 2. Gives me positive 4. Positive 4. Multiply by negative 2. Negative 8 gives me negative 1. Times minus. So minus a 2 gives me 2, which gives me 5. Okay. So here my remainder is 5. And so I want to say that's the same thing as plugging it in. So let's actually plug it in real quick. So if I plug in 3 times negative 2 to the 5th plus 5 times negative 2 to the 4th minus 4 times negative 2 to the 3rd plus 7 times minus 2 plus 3. It's actually easier to crunch it the other way if you're doing it in your head. So this would be 3, negative 2 times that would be minus 14. 3 cubed is 2 times 2 is 4 times 2 would be 8. And since it's negative, so it'd be negative 8 times 4 gives you positive 32. So this is 8, so if I multiply by that 2, I get 16, and then it'd be positive 16, so positive 16 times 5 would give me 80, and so this one would be 32, it would be negative 32, so negative 32 times 3 would give me minus 96, and then if I was going to crunch through this in my head, I'd add these two up, so I get negative 16, add that to here, I'd get positive 16, and then minus this would give us positive 2 plus 3, which is equal to 5. So yeah, synthetic's way better. Yeah, for negative 2, it's not terrible. But if I was going to do like, say if this was like 7, this quickly becomes disastrous, right? This is way better, okay? And so synthetic division is a quick way to figure out, is a quick way of plugging stuff in. Now, in the day of a calculator, does this matter as much as back when I went through school? Not by that much, but this ends up being the same. So it's just a quick way of doing that. All right, so the last thing we want to do is, this is what we really care about for next time, is showing things a factor. So we can either plug it in and get 0, or we can do this. And so here, x minus 1, I'll have 1. Here, this will be 1, minus 3, minus 13, 15, and then 0. So even if you don't have a constant term, you still put in the 0. So, or we could plug it in. And so actually in this case, plugging it in is slightly faster, in my opinion. So let's go through this. And so we want to show this is a factor. What does it mean to be a factor? That means that p of 1 is equal to 0, right? Or x minus 1 has no remainder. So that's what it means to be a 0, and that's what we're really going to care about, and that's why we teach all this. So here I get 1 comes out to be 1. Hold on. It becomes 1, this becomes minus 2 becomes here, so I get minus 2, so I get 15, no, minus 15, 15 becomes minus 15, which gives me a 0, which gives me a 0, which gives me a 0. So here I have remainder 0. So I know that x minus 1 is a factor. Here, if I plug it in, it's actually real easy because 1 to the 4th is that, so it's just basically the coefficients here. Plus 15, if I add all this up, I get 0, right? So this equals 0, so we're good here. So, well, why do I care about this? So let me write this down, why do I care? So x minus 3x cubed minus 13x plus 15, x is equal to x minus 1 times x, so this would be 0, so this would be x squared, x cubed, so this would be 3 x cubed minus 2x squared minus 15x. Okay, but once I'm here, can I factor this down more? Sure, right? So technically, let's pretend I want to completely factor this, and that's the whole point of it at the end of the day. So I have one factor out here. I can pull out another easy factor, x minus 1, x, so I can pull out an x, and then I can have x squared minus 2x minus 15. And then if I wanted from there, I can factor that of x minus 1, x, multiples of 15 that add up to that. So I probably want 3 and 5, or yeah, 3 and 5, and I want 5 to be negative because that will give me more negative here, and that ends up working. So here I completely factored the thing. Okay, it's going to be really good to completely factor things. I'm going to ask you to completely factor things.